So for our next video, we're looking at still using our substitution strategy to solve a system of equations, and this system of equation is going to involve fractions. So our two equations here are 1/2 x plus 2/3 y equals -1, and y equals 1/4 x, take away 5/3. So a couple things going on. First, this is a nice system because it's actually got one that's already solved for y. So we already have one variable isolated, or by itself. So that's good. We don't have to do that step. But something that some people like to do in terms of dealing with fractions is actually just not deal with fractions. So I'm going to take that first equation there, and if you notice, the first denominator is 2, so 1/2 the denominator, the bottom number is 2, and then the second denominator is 3. So if I think about 2 and 3, I want to think about what numbers are multiples of 2 and 3. So if I'm thinking 2, that's 2, 4, 6, 8, 10, and 3 is 3, 6, 9, whatever. What we can do there is then think, okay, 6 is a multiple of 2 and a multiple of 3. So if we multiply this whole equation by 6, we can actually get rid of the fractions. Okay, so at this point, we've got, when we do 6 times 1/2, that's like 1/2 of 6, which is 3. So we have 3x, and then we have 2/3 of 6. 6 times 2/3 is the same as 2/3 of 6, which gives us 4. We can also think 6 times 2 is 12, and then divide by 3 is 4, just however that works in your head. And then we have 6 times -1 gives us -6. Okay, so now we've got a new equation, and there's a few different ways we could go about this. One thing we could do would be just to right now substitute y in where we've got that y, and that might be one way to do it. I think the way we've got it done on your notes is actually, though, we're going to isolate y in this one, and then we can just set both equations equal to each other. Again, especially when we're solving systems of equations, both using substitution and elimination, but especially with elimination, especially with substitution, there's a lot of different ways to kind of go about it. And so long as you get to the right, as long as you get the right answer, if you do different steps, it's typically okay. So what I want to do is get y by itself. So first I'm going to subtract 3x from both sides. So that leaves me with 4y on one side and -3x take away 6 on the other side. And then we have 4y, we want to have 1y, so we're going to divide by 4. So that leaves me with 1y, and that's -3/4 x, take away 3/2. Now you'll notice I actually had the fraction 6/4, but I put that in lowest or simplest terms. It's not wrong to leave it as 6/4, but when we're dealing with so many fractions, I try to keep them in simplest terms, just so that our numbers don't get out of hand. But again, if you do it 6/4, you should still get to the right number eventually, but it just, like I said, the numbers can get a little bit trickier. So now we know that y equals -3/4 x, take away 3/2. We also know y equals 1/4 x, take away 5/3. So I'm going to sort of put this, set both of them equal to each other. So basically substitute in for the y, right? Because we know y equals one thing and we know y equals the other thing, so those two things must be equal. Okay, So we've got, like I said, we know y is equal to one thing, we know y is equal to the other thing, so those two things have to be equal to each other. So that's just what I wrote down. I've got the 1/4 x take away 5/3 is equal to negative 3/4 x take away 3/2. Now, I think in the notes that I gave you, I just sort of worked it out with the fractions. But again, if we don't like fractions, if that is something that like kind of trips us up a little bit, we can get rid of them. So on here, I'm actually going to go over how we would get rid of them again. So just like in the first part there, we need to look at the denominators. If you want to get rid of fractions, you always have to be looking at the denominators. And so we have 4, 3, 4, 2. So we're looking for something that's a multiple of 4, 3, and 2. So you just sort of have to think in your head what that would be like, because, well, and actually the 2 is fine, because if something's a multiple of 4, it's definitely going to be a multiple of 2, right? Because all the multiples of 4 are even numbers. Anything that's an even number is multiple of 2. So we don't even really have to worry about that one. So we're just looking at 4 and 3, and if we're like, okay, 4 and 3 for looking at the multiple, what that would be, the first multiple of 3 and 4, we're like where they line up, is 12. Right, because we have 3, 6, 9, 12, and then we have 4, 8, 12. So that's the first time they all line up, and that works for 4, that works for 3, and that works for 2. So if I just multiply this whole thing by 12, I can get rid of the fractions. So we're going to try that. Okay, so when we do that out, we've got 1/4 of 12 is 3, or 12 times 1 divided by 4 gives us 3. However, that makes the most sense in your head. And same thing, negative 5/3 of 12 is negative 20. So that's like saying, you can do it in whichever order. Like you could do 12 divided by 3 is 4, times 5 is 20, or you could do 12 times 5 is 60, divided by 3 is 20. So again, however you want to do that math in your head, whatever works best for you. So we've got 3/4 of 12 is 9. And then a negative times a positive, so it gives us a negative. And then 3/2 of 12. So again, half of 12 is 6, so 3 of those is 18, and still negative times positive gives us a negative. Okay, and then, so our fractions are gone. That might be a little bit easier for us to manipulate if we don't like fractions. Again, you can do it out with the fractions. It's just sort of up to you what works best for you. So now I need to have all of my x's together, right? Combine like terms. So I'm going to choose, I'm going to look at that negative 9. I'm like, okay, if I add 9x to both sides, that'll get rid of that. Okay, so my negative 9x, positive 9x, that makes 0. And then if I have 3 x's and I add 9, now I have 12 x's all together on that side. Now I'd like to combine all of my constant numbers. So if I've got a negative 20 over there, I like to add 20. So negative 18 plus 20 gives me 2. So I've got 12x equals 2. So remember that means 12 times x. So to solve, I need to do the opposite. So I'm going to divide by 12. So that gives me 2/12 for x, which I have written in lowest terms, which is 1/6. So once we have the value of x, we need to find the value of y. So I'm going to go back to those first equations, and I'm going to use the second one because that's y equals. So I can just plug that right in and work from there. Okay, so we substitute 1/6 in for the value of x, and then we've got 1/4 times 1/6. So if you remember our fraction multiplication, when we're multiplying fractions, we just multiply the numerators together and multiply the denominators together, which should give us 1/24. So now we need to subtract. We need to do 1/24 subtract 5/3. Now, if we recall, when we're adding or subtracting fractions, we need to have a common denominator. So when I want to find a common denominator, the first thing I do is look at the denominator that's a smaller number. So in this case, the 3. And the first thing I want to check is if I can just change the 3 to make it 24 instead of having to change both. So when I'm thinking about that, I'm thinking, okay, 3 times what would give me 24, if anything? And in this case, that actually works because 3 times 8 gives me 24. So to find an equivalent fraction for 5/3 that has a denominator of 24, I'm going to multiply both my numerator and my denominator by 8. Which now gives me 1/24 subtract 40/24. So now that they have a common denominator, I can just subtract the numerator. So I'm going to do 1 minus 40, which gives me negative 39. So there we have our solution, which is x equals 1/6 and y equals negative 39 over 24.